In our previous video, we have seen OSI model containing 7 layers like application, presentation, session, transport, network, data link, and physical. OSI is a theoretical model, while we have TCP IP model, which is practical one and used in Internet. So instead of 7 layers, TCP IP consists of 4 layers. The application layer in TCP IP model is combination of application, presentation, and session. Therefore, it is also handle presentation of data and managing the session. Transport layer is similar in both models. The network layer in OSI model is called Internet layer in TCP IP model, while data link and physical layer combine in one layer in TCP IP model called Network Access Layer. So let's understand the TCP IP model in this video, so watch it till the end. Here in TCP IP model, we have 4 layers. The topmost layer in this model is called application layer. This layer is responsible for handling high-level protocols, and it deals with issues of representation. This layer allows the user to interact with the application. When one application layer protocol wants to communicate with another application layer, it forwards its data to the transport layer. Various protocols are used in application layer, like HTTP, to access the data over the World Wide Web, SMTP for email transfer, SNMP for managing the devices on the Internet, FTP for transmitting the files from one computer to another computer, DNS that maps the name to the address, Telnet for the connection between the local computer and remote computer. Second layer in TCP IP model is transport layer. The transport layer is responsible for the reliability, flow control, and correction of data which is being sent over the network. We are using 2 protocols in the transport layer, like User Datagram Protocol, UDP, and Transmission Control Protocol, TCP. UDP provides connectionless service and end-to-end delivery of transmission. It is an unreliable protocol. UDP does not tell about lost packets. On the other hand, Transmission Control Protocol, TCP, establishes virtual circuit between the sender and receiver, and it is active for the duration of the transmission. TCP is a reliable protocol. Therefore, it ensures all the segments must be received and acknowledged. At sender, TCP divides the whole message into smaller units known as segment, and each segment contains a sequence number, which is required for reordering the frames to form an original message. At receiver, TCP collects all the segments and reorders them based on sequence numbers and get whole message back. Next to this, we have Internet layer. An Internet layer, also known as the network layer, is responsible to send the packets from any network to the destination, irrespective of their routes. IP protocol is the most significant part of the entire TCP IP suite. IP protocols is responsible for IP addressing, host-to-host communication. It determines the path through which the data is to be transmitted, data encapsulation and formatting, fragmentation and reassembly, and routing, by which the IP datagram pass through various devices, such as routers, when your destination is on distance network. Next protocol used in this layer is Address Resolution Protocol ARP, which is used to find the physical address from the IP address. Other protocol in this layer is ICMP, or Internet Control Message Protocol. ICMP is used to give information about any problems occurs during transmission back to senders when datagram is undeliverable. Network Access Layer. A network access layer is the lowest layer of the TCP IP model, and that is combination of the physical layer and data link layer defined in the OSI reference model. It defines how the data should be sent physically on the same network. Network access layer are encapsulating the IP datagram into frames transmitted by the network and mapping of IP addresses into physical addresses. The protocols used by this layer are Ethernet, Token Ring, FDDI. We will study all important protocols of TCP/IP stack in upcoming video. Till then, bye-bye.